Welcome everyone to a new and special episode of the Tek Caffe Podcast. I'm your host, Ahmed Misbah. Since launching Tek Caffe in 2023, our mission has been simple: to empower the software development community through insightful and inspiring conversations. Over the past 3 years, we've had the privilege of learning from some of the brightest and most inspiring minds in our industry, including Uncle Bob, Tim Oettinger, Jeff Langer, Mark Richards, 𝗔𝗴𝗶𝗫𝗍𝗶, Andrew Clay Schaffer, and many more. Each conversation has been a chance to explore the ideas, principles, and practices that shape the craft of software development. Follow us on LinkedIn and YouTube to catch up on previous episodes and stay updated on the upcoming conversations. Today, we are honored to welcome someone whose contributions span 4 decades of software engineering, from the mainframe era to the Agile revolution and technical excellence, James Grenning. James has been writing software since the late 1970s. He is the founder of Wingman Software, where he trains, coaches, and consults with teams worldwide. He was one of the 17 signatories of the Agile Manifesto at Snowbird in 2001. In fact, James coached his first extreme programming team in 1999, bringing practices like test-first development and pair programming to teams when these ideas were still radical. James invented planning poker, a technique now used by Agile teams worldwide for collaborative estimation. He's the author of Test-Driven Development for Embedded C, a groundbreaking book that brought TDD practices to one of the most challenging software environments, helping embedded developers worldwide improve their code quality and development process. He created the zombies approach to guide test design and test-first programming, and he's one of the authors of CPPU Test, an open-source test harness for C and C++. James contributed chapters to Uncle Bob's Clean Code and Clean Architecture. His work bridges embedded systems and mainstream software development, bringing decades of experience in TDD and Agile practices to some of the most challenging technical environments. In today's episode, we'll take a journey through time, from programming in the 70s and 80s to the creation of the manifesto at Snowbird, to test-driven development in embedded systems, and to the future of software development. To our viewers, live viewers, feel free to post your questions in the chat. We'll try to take as many as we can near the end. And now, without further ado, James, welcome to Tek Caffe.
Well, Ahmed, thank you very much. It's quite an introduction. You're very kind.
You're most welcome. It's an honor to have you with us. So let's start with our first question. You started coding in the late 70s. Can you print a picture for us? What was it actually like to write software back then?
I'm going to go a little before then. I'm going to switch my view here for a second. So I had a friend programming in high school, and it looked like a terrible thing, and I decided I'm going to stay far away from that. So that was the first thing. But you might say, well, James, how did that work out for you? Because here you are. I had to do some programming in a calculus class, and it was the only one that fit my schedule. And, as a young man, schedule was more important than anything else. And so we had to go and simulate calculating the area under the curve the way Newton's method, which led to him discovering integral calculus, was done on a teletype, so basic programming. And I realized someone would pay me to do this. And so then, in my career, somebody handed me this 8251 device spec, and now I'm an embedded systems engineer. The degree was kind of EECS, although they didn't really call it that. And look, I'm not careful enough to be able to get one of these machines started.
the guy that I worked with in my first job, he would toggle in the zeros and ones to boot the 𝗖𝗽𝗽𝗨𝗧 8080 to get it smart enough to be able to talk to its floppy drive. And, all kind of primitive stuff back in those days. And you see those little devices there with the little windows on them. We would program these, and then when you got your program wrong, you'd put them in a little box with UV light, and it would erase the devices. And then the turnaround time was not great. You see in the background, there's a logic analyzer. The tools were, EE style tools for debugging software back in the late 70s. Probably a lot of this being done still. Logic analyzers. We had this thing from Intel, the blue box. And you can, they didn't keep the keyboard on top. That's the only picture I could find of it, when you're asking about some of this history stuff. But it holds 2 8-inch floppy drives. And when it started doing its job, it kind of sounded like where you're compiling a program. It would take hours to compile it and then use these things that go in circuit. But, that was some of the fun of embedded systems programming back in the beginning of my career, in my first job.
Oh, wow. So what languages were you using back then?
Well, in university, there was first programming language I touched was BASIC. And that was that area under the curve. And then when I found out you had to take other programming courses, then there was Fortran, which was on punch cards. It was everything I didn't want it to be. But programming was kind of fun. It was a challenge then, like solving a puzzle. And so the punch cards, you'd type them up, you'd give them to somebody, you'd come back an hour later. So there's a lot of inspection we'd try to do to not have that compiler error. And I think I once had one deck of cards where I turned it in the first time, and there was only one error on it, which was an amazing feat for the day. And it would take you a while to get your feedback back. And then, of course, in college, they also had some obscure languages, Snowball, a string-oriented language. I never had COBOL, thankfully, PL1. And finally, C. Unix and C were in the lab, when you get into the advanced classes, Unix and C. And you could crash the whole Unix system because, it was a bad pointer would cause some bad stuff to happen. It was pretty interesting. So that's how we started. And then when I got in my first job, we built with the FAA. We were contractors to the FAA. Small group of people. We built the first color weather radar display system. So now when you see weather radar images, that's all an evolution. Well, not of our system, but of the idea. We built the first one for the FAA, where there'd be 8 different colors for the weather. And we had an 8085 that ran the keyboard, and we had an 8086 that ran the graphics engine with specialized hardware. You had to build it ourselves. And we had 12K of RAM and 12K of ROM for each of those processors. And thankfully, by the time we got stuff working, 16K parts were available, so that we had a chance of cramming all the code in there that we needed in 8086 and 8085 assembler with a 1 megahertz processor. I'm just trying to, back to all the little funny things that were going on back then. So that's a little bit about it. That was job number 1.
So I've read and heard that test first programming actually dates back to the Mercury project, where you had to write the expected output on a punch card and then write your code and give it to some mainframe operator, and then he would give you back the results on punch cards, and you would compare the actual output with the expected output. Was this the way people did programming back then?
No. Well, maybe NASA did. They were smart there. And Kent and Ward, inventing this stuff,
I'm still kind of in awe at them. They could actually see past the problem right in front of them to say there's a better way to work, but I'm sure we'll get into that in a little while. No, we were writing code and debugging it into working. We were doing debug later programming, as I like to call it. Write a bunch of code. Yes, I've got it right for sure. Doesn't work. Now you start the small steps of debugging, right? Get it to work. My boss, I remember this on like the second day of work, he came to me and said, okay, so here's the system we're building. Here's your part of it. And we're going to get hardware in about a year. And that's when the integration nightmare, I'm going to change some of the words a little bit to make it PG. That's when the integration nightmare happens. And we've got like 6 weeks to get it all to work. So go ahead and work for a year open loop without any feedback. And then, in a year, we're going to have 6 weeks to get it to work. That didn't work very well. It never got done in the 6 weeks, I'm saying. So.
Well, I'm a bit surprised, but because when we are trying to sell TDD to mainly mainstream developers, we always tell the story of how test-first programming dates back to the mainframe era. So thank you for telling us this wasn't the case.
Well,
but yeah, but
I'm not disputing that your story was true. I've heard similar story from Kent Beck with paper tapes, right? So the guy that was programming paper tapes or whatever. But so I have no doubt that people were doing it. We weren't smart enough to. I did see something like it once. We got a spec from the FAA saying, here's the system we'd like. And then they also gave us a page that had a bunch of test cases on it. It's like, why are they telling us about test cases now? Because test is at the end. We don't, we weren't smart enough to know that you could do tests. You could start to think about tests in the beginning, so.
Yeah, but it's interesting to learn that both mindsets existed at the same time, which is still the same case till today. I mean, we've got people doing test last and people doing test first. So it seems that this is how the industry has been and will always be. Hopefully, will not be that way in the future.
Yeah, hopefully.
Okay, so let's talk about software design in that era. So Ed Jordan and Larry Constantine had published their work on structured design, introducing coupling and cohesion. Did you encounter these concepts early in your career? What was your experience applying them?
They probably got mentioned in one of the later CS courses, at the university. They were vague ideas, coupling and cohesion. Hard to really make sense out of them. They weren't in everyday vernacular at my first job. Now, my second job is where I met Bob Martin, and we can talk about that later. But so he talked about it. So that was something that we were talking about in the early 80s at a company we worked together at Teradyne. But my first job wasn't really much. Then our first contract was this FAA system, and then the second thing we got into, there was a lot more interest in the structure of how we're going to do things. It was kind of a waterfall approach, the first formal kind of method. We were contractually being held to do that, and that was interesting introduction to kind of thinking about stuff besides just at the whiteboard that you're at with your friends that know what that think we know what we're supposed to do. So coupling and cohesion, I got to tell you, coupling and cohesion didn't mean as much to me until we started talking about solid, and then could relate coupling and cohesion in the context of the solid principles, where you had single responsibility and dependency inversion. Those two things, single responsibility, that's about the stuff that goes together, and dependency inversion is about separating stuff that doesn't go together, right? Interface segregation also, we'll probably say something about that later, how that kind of fits in. So, but no, not really big in the beginning.
So other than coupling and cohesion, were there other design concepts or principles influential at that time?
Well, you get out of school and then you're one of 3 software engineers and you think you know everything because it's a brand new field and you don't realize how much you don't know, okay, until you're a little more seasoned like me now. So I'm not saying the industry wasn't. I'm just saying my path, we didn't have a lot of that in the beginning, okay? There would have been one advanced architecture course at the university. Jordan and Constantine might have been mentioned. Structured programming, structured design, and data flow were things I bumped into when Bob brought in somebody to teach us those at the company we both worked at, Teradyne. And so the structured decomposition made a lot of sense to me. That seemed to be, okay, I think we're doing this already. The data flow models and that sort of thing were very kind of mind-blowing because I was in more of a transactional mindset. Call something, get a return result, do something with it, right? Kind of a command and control center rather than here's something, I did my work, I'm sending it somewhere else. So the data flow thing for these embedded systems we were building didn't make sense to me as a solution to the problem. Now, Bob designed an interesting system where that was the core, that was the architecture, and he had me reviewing stuff, and I couldn't get it to fit it up here at that time. It's like, why are you doing it like this? And I'm not sure. I think a lot of things, like if you go to Unix and put together your filters on the command line to take something and transform it into something else, those ideas seem to work really well for that, and they were embodied in that environment. But in a embedded system that's responsible for controlling hardware and software and a user experience and that sort of thing, it didn't make sense to me, the data flow part. But the structured programming, not structured programming, structured design, decomposition, that sort of thing, we use those ideas. We also did a fair amount of pseudocode. Turnaround times were kind of long to do a compile. And also before we'd have hardware. So we do pseudocode, and I'd, get Bob to review some of that stuff for me. We'd socialize that around the group and try it so that when we actually wrote the code that it was going to work, but it never did, so at any rate, I mean, it did eventually, but not right away.
So it's interesting to learn that you and Bob go even before the Object Mentor.
Yeah. So I like to play pool. I like to play foosball. I know you know those sports, right? Those activities.
I know the first. I don't know the second. Yeah.
So table soccer.
Okay.
With the rods and the handles.
Okay. We call it baby foot here. Okay.
Yeah, okay, baby.
Anyway,
baby foot. I used to play a lot of that. I was playing that at the local bar, and a friend of mine was a headhunter, and he, after I probably won, after playing him, he said, there's a company nearby here that I keep trying to recruit people out of. No one will leave, and they've got an opening that would be great for you. And this is during the time of the Carter administration and super high inflation, and there's no way to get ahead except by changing jobs. So after 3 years with one company, I went on an interview at Teradyne, and I met a couple of people there. And the first person, it didn't sound that interesting, testing the copper wires that run between the telephone office and your telephone. Didn't sound that interesting. And then I talked to Bob, and there would be like nothing more interesting to work on than testing the wires between the telephone office and the telephone. And so because of kind of our interesting connection at that interview, I did take a job there, and I spent 15 years with that company. Bob's probably was there another 8 or so before he went somewhere else. But so that was our roots together. And so we didn't work together there. We were like in neighboring departments and, shared some ideas at that time. Yeah.
Well, that's That's interesting.
We were putting 8085, or we were putting C code on 8085s.
Oh,
Now, if anybody in embedded might know what that means, an 8085 has a memory space of 64K. And so you could arrange it for 64K of RAM and 64K of ROM, but you can fill that up with the C compiler really fast. So that was one of our challenges.
yeah, these were interesting times. I mean, I started coding in 1989, and I remember that was on an Arabic version of the Commodore 64. It was called 𝗔𝗴𝗶𝗃𝗀𝗃𝗃, and I think we were writing BASIC, if I remember.
Yeah.
But of course, I was just 5 years old back then, so I didn't really get the memory stuff and all of that. We're just write code to do the following thing, and that's it. If it works, you're a
That's right.
great student.
Yeah.
Okay. Okay, so let's move to the 80s and 90s. So the personal computer era was beginning. Languages like C++ were emerging. We had early IDEs like Turbo Pascal, but developers were still working with tight resource constraints, manual debugging, floppy disk backups. How did your work change in this decade? What were you building, and how did the tools and practices evolve from what you experienced in the 70s?
Yeah, so PCs didn't infiltrate us much in development in the 80s. There were some in the second half. I did buy a Macintosh, early, probably first version Mac, because we wanted to be able to diagram design ideas. So that was one of the graphic things we could do. But the way we were doing building our software then, all cross-compiled. So one of the things that embedded systems people have to deal with is that the processor you're going to run on is not the processor you're building on. And so we had a big VAX. I think we started with Tek PDP-11s at first, and then we got a VAX, which is digital, no longer with us, I think Digital Equipment Corporation, DEC. They had the VAX. And so we would compile on our workflow would involve editing and compiling on the VAX, and then that would produce a binary that we could then load into either an emulator or burn into those chips I was showing you to try out our ideas. And everything would take a long time. And at one point, I think I did win the most compile time CPU usage for any one given day of our whole group of 100 engineers, because just one little mistake means another build, so we were having to do that. It was unfortunate, but that was the environment, cross compilation. PCs, there were a few people using them maybe in the second half. They were being used in business, of course, but in engineering, at least in my group, we didn't have a big use for them. Most of our stuff was built on a VAX or something similar, and then cross-compiled down to the target system, whatever that might be.
Yeah, so I guess for engineers, it was much different than for normal end users.
Yeah, the platform, the PC platform would have been, great because it's got a, commonality, and, computers were all pretty special. I mean, you had a terminal on a bigger computer. You didn't usually have your own personal computer unless you built one from a kit, which of course I did, an S100 bus with an 8085 or a Z80 or something on it. And I finally threw it out like about 5 years before I should have, and then I would have kept it and had it for posterity. But, another thing you mentioned, C and C++. So Bob came to me because he was interested in using C++ in our products. And he came and pitched me one day for my group to use C++ for our product. And it's like, this is probably 1987. And I was like, oh no, that's too much risk. We're not ready for that.
And then shortly thereafter, Bob left Teradyne. I'm not saying there's any cause and effect, but he went and joined a startup for a while after that. And then after he got done with the startup, then he started consulting, and then he started saying, hey, you should come and join my consulting company. And we're doing all the C++ and OO. And it's like, well, I don't know any of that. It's like, well, you should start learning it. So started learning it, and then eventually could join him.
Okay, so we were talking right now about C++. So we are basically talking about object-oriented programming. So I guess in the 90s it had matured. Gang of Four, 𝗏𝗏𝗏𝗏 et al. Published design patterns. The internet arrived. We saw automated testing and continuous integration emerging. Then in 1999, Kent Beck published Extreme Programming Explained. You write that you attended the first XP immersion training in Deerfield, Illinois, and that week at the Marriott had a profound impact on you. What was it about XP that clicked for you? What did you see at the immersion that made you think this could actually work?
Yeah, so well, your question had a lot of stuff in it, some lead-up stuff we might come back to, but what struck me about extreme programming at the time is kind of the approach to make somebody open their ears and listen, which would be talking about what problems are being addressed. Okay, so right now, test-driven and Scrum and all these are seem like they're being pushed on people. Here, you should adopt these. Why? That wasn't how extreme programming was sold and how we would try to sell it to people in the early days. We would, there'd be some interest usually of a brave person would say, these are good ideas, we should do something, but most organization wouldn't be there. So in extreme programming immersion, Kent would talk about the problems. So what problems do people have? Do organizations have? And inevitably, every client we talked to over the next 5 years after this, we would always, and I would still to this day, if I was going to coach a client, I would want them to identify their problems. What problems are you experiencing? And sometimes they're going to be reluctant. Okay, that's a bad sign if they're reluctant to express their problems. But if they'll be honest with you about their problems, what you're going to hear is, we don't like being late. We don't like delivering crap. We don't like burning everybody out. And, when we're going to be late, there's no warning that we're going to be late, right? You wait until the last possible minute. And then, so we'd hear that story over and over again. It's like, oh, okay. Okay, so any one of those problems, you can build a fairly short logic chain from that problem to a solution in extreme programming. Okay. So if we're going to be, so we develop the spec and everybody wants everything that's in the spec, but everybody knows the spec doesn't stay that way for a year. Right. And so, and you get someone to say yes to that, you go, well, then what could we deliver? What could we show in the next 2 weeks or in the next month? Right? What if we showed you something like that? Oh, but that's going to cause this problem. Well, what if it didn't cause that problem? What if we could make progress by showing what works? Okay, then we could get feedback because we've all experienced give me this feature. Here's the spec for it. Oh, gee, thanks for giving me what I asked for. I need something different, right? And so people, if you're telling their story of the problems that they've experienced, now you've got their interest if you think you've got a solution to that. And so for me, in the extreme programming, we'd gone through waterfall. I went to the meeting, to the training with waterfall's still a good, the way to work, not knowing what extreme programming really was yet when I went, and now finding out, how about being late? Yeah, we're always late. How about delivering defects? Yeah, we deliver defects. How about you're not warned until you're late that you're going to be late? Yeah, that happens. Everybody's burned out because of death marches. Yeah, all that. You mean there's a solution to this? And then we start looking at the different pieces. Then one of the pieces was I'll say, in hindsight, jaw-dropping, which is Kent's demonstrating test-driven development. He's working in Java. And, most embedded developers of that era, if they saw somebody programming in Java, they would tune out and, it doesn't apply to me. But I'd worked in embedded, and then also I was with Object Mentor at the time, Bob's consulting company. And so we were not just working in embedded, we were working in other areas as well. And so we would see Java, we'd see, C# didn't exist yet, but we'd see C++, C, and Java in our travels. And, so when I'm watching Kent do this, it's like, oh my gosh, he's testing his code before there's anywhere to run it. I'm an embedded systems developer. What is one of my problems that I have? I don't have anywhere to run my code until 3 months before I have to deliver it. And we're working
exactly.
on it here.
Yeah.
And this might be important. So I'm like totally awake now. And the next week I was working with Motorola, as a matter of fact, in the Chicago suburbs. And I started socializing the ideas with them, and they were afraid of them. But we managed to get our director, to kind of hear me, the new guy who's never done it, pitching them on doing it and trying to coach them through it. And he said, this just might work. And so we had a green card to go and, a get out of jail free card to go and try the ideas out. And it worked really nicely for them. But anyway, that was kind of my long-winded answer to that.
But it's actually a great story because the way Kent Beck pitched XP is actually great. He listed the problems that we still face till today, and will grab anyone's attention. And if the next thing you're going to say is a solution to these problems, bring it on. Let's hear it. I also like the part about how TDD makes a lot of sense to embedded programmers because, most of the time, you still don't have the thing you're dependent on ready for you to start working and try stuff out.
Well,
so,
I'm not sure that TDD makes a lot of sense to all embedded programmers. It made sense to this embedded programmer that had 20 years of waiting for hardware. I never thought there was any other, we do little experiments off on other computers, but it was never, serious, a continual process. It should be. But I would like to see that more embedded developers would embrace this, even if they did test after, test just after and structure their code to be tested, right? So neither of these things are givens. And in most embedded, a lot of embedded developers, I can't say for most because I'm not seeing as much these days, they work in isolation, a lot of them. Now, with some of the larger embedded systems, now they can't work in isolation. And so these ideas are making their way into those places. And there's actually now companies, there's a company called 𝗔𝗿𝗵𝗵 that they're trying to help. They've got a similar mission to mine, although they're not teaching TDD, but they have this mission of bringing modern practices to their clients, which is, kind of been my mission, which it's not done yet, but there's millions of embedded developers that are still doing things with debug later programming.
Yeah, we'll get back to that in the coming questions.
Yeah.
So
hey, one thing I wanted to mention about
sure.
If there's any consultants out there in this leading with the problems, my worst ever client was it was great. I got this client called me up and said, hey, we want you to come down and teach our embedded team. We're in a medical field and blah, blah, blah. We think that, you'd be a great fit for teaching them extreme programming. And so I get there and I do my usual thing and sit down with the team and say, so what problems are you guys trying to solve? And they all kind of look around at each other and shrug their shoulders. Problem? No problem. They all say, no, there was no problems. It's like, well,
usually when, somebody invites me to come and work with them, there's some problems you're trying to fix. It's like, no, that's not us. And by the way, we didn't want you here. It was our boss's idea.
Yeah.
And okay, so consultants, if that happens, you need to fire them right away. Okay. I stuck it out with them because I thought I could help win them over, and they, helped make my year. But it was after that I started vetting my customers more carefully, because it was very painful to go work with them and they got nothing from it, and it was very aggravating for me. So that was so I learned that lesson in about 2009, I think. So important lesson. You got to qualify your customers. Make sure they're ready.
I did a short on YouTube and LinkedIn discussing exactly the same problem, because 3 years ago I went as a consultant to a big telco company in the Gulf region, and we were supposed to help them with their agile transformation. And we were with this big VP, and we started explaining what agile is. And the first thing he said was the same thing you just mentioned in your story. We don't have any problems. Why are you here?
Nobody told them.
Yeah, I mean, you're saying that you're going to be making our lives better, where our lives are already good.
Okay,
yeah, we all stood there and we were like, okay, we're in trouble. But it's funny that it happens with a lot of people and with a lot of consultants. And that's why a few weeks ago I said, before you go and do consulting, the customer has to be ready. He has to understand why the consultant is coming, what is he going to sell, whether this thing is actually worth selling or not, but not simply surprise them. Hey, I'm here to solve this problem and that, and then, we don't have any problems.
I'm here to teach you Scrum. I'm here to teach you XP. Why do I want to do that? Yeah, interesting.
So what you're saying makes a lot of sense, and it's funny that it happens with a lot of people. Yeah,
I think that I'll just grouse a little bit about the Agile community too, because I used to go to the Agile conferences all the time, and I went a couple of years ago, and I wanted to see if other people are doing that. So I said, what do you do when you're starting out with a client? And so I asked a number of really nicely regarded coaches what they do, and none of them offered that as one of the things that they start with, which was kind of surprising to me. I was trying not to add leading questions and to, change their mind or anything, but it's like, I just wanted to see if other people had that approach. And I think that has hurt Agile, because people are interested in doing Agile because they were told to, not because it's solving a particular problem. And, if we took this problem solver approach rather than dogma follower approach, I think you'd be better off. But it's way easier to teach dogma, right? It's a lot harder to think about problems and solve them and connect solutions to problems. So
you're absolutely right.
Yeah.
Okay, so we were talking about Agile. So let's now talk about the birth of the manifesto and the Snowbird meetings. So you were one of the 17 people who gathered to create what became the Agile Manifesto. Can you take us back to that meeting? What was the atmosphere like? What were the conversations?
Yeah, okay, sure. Well, I'll just start up by telling you the truth, which is I went to go skiing. Bob says, do you want to go to Snowbird and meet and blah, 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 blah? And it's like, yeah. I mean, for work? Yes. And so, I mean, that aside, got that over with right away, because that is the truth.
I'm starting to think you got tricked into it.
No, although I would have gone knowing what the meeting was anyway. But as soon as Bob, you want to go to Snowbird for this or to the Caribbean? It's like, yes, definitely I can make it. When is it? What are you going to talk about? But anyway, so he and Alistair, I think, were the main driving forces there.
It ended up in Snowbird because that's where Alistair lived. It almost ended up in the Caribbean because a different Dave Thomas, there's two Dave Thomases. Maybe there's three Dave Thomases. One is Wendy's hamburger place, and then there's two other ones. Caribbean Dave Thomas, wanted us to go down there, but whatever happened, we ended up in Snowbird. And it was an interesting group. I was part of the extreme programming contingency, if you will. So there was Kent and Ward, the guys who started it all, building oscilloscopes for Tektronix. And then there was Ron Jeffries, one of the first extreme programming coaches, Martin Fowler, Bob Martin, me. That was the kind of the extreme programming group. I was learning from all those guys. It was a great, wonderful thing. I would go there just to learn from them. And then you had John Kern and Steve Meller were both in the kind of the modeling world, although different approaches. Steve Meller would make the model and then write code to cause the model code to be generated. And then John Kern was in the tooling that would make object-oriented programming diagrams appear from your code, right? So two different approaches, but very into modeling. And then Ari was kind of a more, I think, on the business side. At least that's my impression from that meeting. But bringing European perspective of DSDM, which is kind of a management approach, right? And then Alistair and Jim Highsmith were, well, Alistair's very technical. Jim was more management focused, but they collaborated a lot. There was kind of a funny joke about the name of their business should be Cocksmith or something like that, but because Coburn is spelled Cockburn, but if you ever are with Alistair and you say Cockburn, he will make sure that you pronounce it properly as Coburn.
Yeah.
And so we had some laughs about that, but at any rate, so that was the people that were there. So there's a lot of extreme programming influence, everybody. I think Bob knew everybody there from, you mentioned the patterns, Gang of Four book. And so there was, in the late 90s, there was the 𝗬𝗏𝗄 conferences, object-oriented pattern something. So a lot of the extreme programming ideas first were introduced at 𝗬𝗏𝗄. And so I think a lot of these people got to know each other there. And I think Scrum was introduced at 𝗬𝗏𝗄 too. And so between Bob and Alistair, they knew all the people, and that's how they ended up together. And some others were invited that couldn't make it or whatever. Okay, so then what's your follow-on question?
So I wanted to know how the Agile Manifesto came about. I mean, what conversations did you guys have? You've told me before in a very short class I attended with you that, what you've said right now, people were coming from different backgrounds. So how did you find the common grounds?
Well, that was interesting because we could do a lot more of that today, which is we would look for what we agree on. Now, if you think about the world today, we look for what we disagree on and focus on that. Okay. If you looked at politics in the U.S., in the world, what don't we agree on? Let's argue about that. Where you could decide to instead find what you do agree on and make progress with that. That was, I forget where that came from. Oh, that actually, I'm not sure how much it influenced this meeting, but in the 80s, the company Teradyne, where Bob and I both worked, we were learning total quality management skills. And one of the skills was brainstorming. And where we'd brainstorm, first you would write down your ideas and then you'd get them out there. And then you would discuss them and you'd find the things that you could agree on, because then you could take action on that. It was a very action-oriented thing. And at the time, I probably wouldn't have connected the dot here, but in retrospect, because we'd been using those techniques that came from Teradyne in our daily work at Object Mentor from time to time, that it was pretty natural for us to bring out the note cards and and start this conversation about what do you think about our movement or whatever, so a small part that I might have played that day at the first meeting, a friend of mine told me about, I forgot all about it, so this is hearsay now, even though I supposedly did it, is I brought the note cards. And when we started the conversation, I opened up the note cards and said, okay, everybody, write down your ideas on these cards. And then, so whatever question was posed, I don't remember. John Kern took a lot more notes. He might have better recollection there. Have you talked to John on your podcast yet?
Not yet, but I heard a similar story from the late Mike Beadle on another podcast.
Yeah,
he told me that on that podcast, he said that the note cards idea from the ex-peers is what actually saved the meeting.
Oh, okay.
Yeah.
Mike came there really as a Scrum advocate too, and I'm sorry I left him off the first, run through the roll call. I don't know I'm sorry if I missed anybody else, but so the note cards got us to find out what we agreed on, and I got to say that has to have come from Teradyne's TQM movement, which we thought as software developers was a complete joke and a waste of our time, because our manager came to me and said, James, you need a TQM project. It's like, that requires a short cycle time. Our cycles are 6 months or a year. We can't do a continuous improvement project. Too bad I didn't just immediately then invent test-driven development and extreme programming, but I wasn't smart enough. We needed Kent and Ward to do that. But so that got things started, and then we spent a lot of time kind of respectfully taking turns arguing, and there was some people were more talkative than others, and the word code would have been in the Agile Manifesto, except for Steve Meller, and maybe John Kern, but Steve Meller, every time a phrase was put up with code, he goes, "Oh, don't you mean software?" Because his model, what if we get an executable, something to execute that was created from a model? It's not code, right? It's a model. And so he was being very particular that we didn't let code be in there. And that was good because that makes it a bit more abstract. And I think, I know one of the things, extreme programming, with the name extreme programming, scared too many people away. And I think the branding was something we spent a fair amount of time on too. And not the principles and then what to call it. Not that we thought anybody would care afterwards. We didn't really think anybody would care. But one of the things Ward said to me right in the beginning, he goes, because the title of the meeting was the Lightweight Methods Summit. And, it was in Utah. It was close to the top of a mountain. It wasn't quite at the summit, but it was, higher than most people around. And he said, we're going to need a better name. It's like, well, why? What's wrong with lightweight? Because, there were heavyweight processes around then. Like Motorola's process was stifling. You could barely write a line of code every 6 months at Motorola. Really heavyweight processes, so lightweight was appealing, right, to unburden. But Ward says, well, you can't be called lightweight. Who wants to be called a lightweight? And it's like, it was a good joke. Yeah, okay, true enough. So then we came up with something else. And some of the other candidates, I remember two of the candidates. Agile was one, and Adaptive was another. But Adaptive was already kind of taken by Jim Highsmith, and we wanted something that didn't align to any one of the contingencies that was there. So Agile was the name, and we didn't think anybody would care. Ward said, I'll put up a website about it, about our 4 bullet points. And then surprisingly, some people cared.
The whole world, actually. Yeah, that's a great story, James. Thanks a lot for that. So let's move to what happened after writing the manifesto. So shortly after that, you invented planning poker, a technique that is now used by Agile teams to size work or estimate their work for those coming from a non-agile background. So can you tell us that story? What problem were you trying to solve, and how did Planning Poker come about?
Yeah, okay. So I was in Utah, where I spent quite a bit of time in Utah. That was, so we were working with Symantec. I'm way past any NDAs, so this is all just history now. I was working with Symantec in their internet security group, and we had an advocate there that we were teaching extreme programming to. It was kind of funny how the business came to be. Our advocate, his name was Carlos. He called Bob, and Bob had taught their group design and design principles and all that. And he called Bob and said, "Bob, you got to help me kill this thing that just came into our company. These guys want to do extreme programming." And Bob said, "Well, actually, Carlos, you don't want to kill it. It's actually a lot of good ideas. We should come and teach it to you." And so that ended up turning into a really huge job for us. We had several, it was half a year long probably, and several coaches there at a time. And one of the roles I was playing there was business coach. So we had technical coaches and business coaches, and I could wear either hat. But because I had more business background from management stuff I did at Teradyne, I got the job of business coach. And we had done not a lot of this stuff at the time, but here we are with the group, and so we're trying to plan out their next iteration. And so there's 6 of us or 8 of us around a table, and there's 2 of the principal chief engineers on this project, and a story would come out. It would be too big because we didn't know how to slice anything yet, because this is all still new to everybody doing it, except for Kent and Ward. Although I think it was, okay. So how do we slice our work? Nobody really knew how to slice anything. So the story would go out there, and the 2 experts would talk for an hour about the story, and then they'd write down 2 weeks. The next story, the 2 experts would start talking, and they both would say, "Yeah, I think it's about a week." And then for the next hour, they would talk about why they think it's a week. And then the next story would come out. And again, the same pattern is and I'm supposed to be facilitating this meeting, and I've only got one more day left at the client, and we need to get through this. And so, a problem usually leads to, is there anything we can do about it? Okay. And being that we would have note cards, I'm surprised I don't have any note cards right here. Oh, I do have some. Okay, so the first ever Planning Poker card deck was something like this, except 3x5 cards, not these big 4x6s. And I had everybody take a break, and I asked them when they came back, "When you come back, we'll talk about the story, and everybody's going to grab a note card, and then you write your estimate on the note card." Okay, so we don't care how you're going to do it. Just give us your best guess as to how long you think it's going to take. And, so note card, now all the people that were sleeping in the previous meeting now have to wake up because they're all playing the game. Okay. Before, with the 2 guys talking for an hour, everybody else is zoned off doing something else, blah, blah, blah. I couldn't cut them off because I didn't, it's their domain. I didn't know what to do. But so, okay, now write your estimate, and then all at once we'll reveal. This was part of this Teradyne TQM influence. I not articulated at the day. I wasn't thinking, "Oh, you're doing this thing," but in hindsight, how I thought of it that day was because of that history of silent brainstorming. You want to get all the ideas out, otherwise, you can apply this technique to all kinds of stuff. Way better than for playing poker. Actually, I'll tell you later, I don't recommend playing poker anymore. But silent brainstorming is very powerful. Get the ideas out and on the table. Then you find out that, my crazy idea, actually somebody else had that same crazy idea. So there's 2 of them on the table now. Or maybe mine's all still by itself, but we talk about each one in a non-judgmental way. Maybe you're judging them, but it's the idea's on the table. If I said the idea, the crazy, stupid one first, everybody would shoot that idea down and it would be gone. Okay.
and everybody else would be afraid to put their idea up. But if we're all writing down an idea at once, put it down. Now we have a discussion about that. Now with these numbers, we weren't going to discuss really if we agreed, nothing to discuss about, put it in the done pile. If we can't agree, try a couple rounds. Hey, you person that think it's so easy, why is this easy? You person that thinks it's so hard, why is it hard? Let's do another vote. Or not another vote, but another round. And then another card gets played. And if they converge, we're done. And if you go a couple rounds like that, you go, well, we need to learn more. We can't work on this one yet. Put it off to the side. So it was this filtering of, are we able to work on this stuff and agree on what's involved? After a few rounds, guess what? People are sitting here behind little decks of cards, and it looks like you're playing poker. And Bob had been encouraging me to write some stuff about what I'm doing. And so I thought, I'll write that paper about planning poker. And I named it Planning Poker because, okay, it looked like we're playing poker, even though it has nothing to do with poker. Now, the next time I go to the client, though, this is kind of funny. One of the main bosses not the main boss that hired us, the middle manager who's being threatened by extreme programming and, we don't need you as much. He drags me aside the moment I walk in on Monday morning, puts me in a room and says, you guys are making this stuff up. And I had to clean up the vocabulary here. I read your paper about planning poker. You're making all this stuff up. And it's like, we're solving problems. I'm not sure how well I did being, put on the spot right there. But hey, what we're doing here is trying to help solve problems. And, a lot of this stuff no one's done before. So, yeah, I guess we are making this stuff up. I didn't exactly admit to it that way to him. But I did try to justify my actions as trying to solve his problem. So, at any rate.
That's a great story, James. Yeah. And you've mentioned that you don't promote planning poker anymore. So we use planning poker when the backlog is not that big. But when we have a big backlog, we use relative estimation. So is that what you had in mind, or are you using some other ways of sizing stories now?
Yeah, so the next part of the story is my one of our other 𝗘𝗺𝗃 alumni, Lowell Lindstrom, who I think I might see today, actually. He was our head business coach at 𝗘𝗺𝗃. Or he was our TQM coach for a while at 𝗘𝗺𝗃. So he had ingrained a lot of this TQM stuff. And he was, the manager at Bob's company, kind of the CEO of Bob's company. And after us teaching people about planning poker for a year, he goes, hey, why don't we try this other thing? Remember in TQM, we did affinity grouping. And maybe this would work on bigger backlogs. And so, sure enough, on big backlogs, planning poker is tedious and a big waste of time. But on a big backlog, you can take all these things, lay them out on a big table, and then start to move them around. And I actually wrote about this on my blog. I call it the Planning Poker Party. And I suggest one of the things which also comes from TQM was the silent part. So we try to go to the table and just thoughtfully and silently move stuff around. And if things can't hold still, then you might pull them out because, different people have a different idea what it is. And it's hard to keep people from talking, but generally make it a silent activity. And then, because of the benefits of not tainting each other's, what do they call it, telegraphing or whatever. So these, those techniques are really quite valuable. And but so that's what we do now. We stopped pretty much talking about planning poker. You could use planning poker on the groupings. Okay. I kind of object to this Fibonacci sequence you find on all these planning poker decks because, the number 13 seems kind of precise. It's different than saying 10 or 15 or 20. 21 sounds very precise too, because that, how many significant digits are there in this number? So
Mike Cohn's idea of putting numbers to it, fine. You have to print something on the cards. I would have chose currency values if I was going to print cards. Because there is a $1 and a $2 bill here in the U.S. currency values anyway. There's a 5, a 10, a 20, a 50, a 100, and then, after that, there's nothing. The uncertainty implied by those bigger numbers is really, I think, the important part of the gaps. And one of the, if you are going to use any kind of numbering system, you really want to specify how uncertain the future is. And the only things you can really work on are the things that you might give a 1 or a 2 to. Even a 5 is probably too big to work on. And, I still see, teams and discussions about, oh, we put this 13-point story in there. It's like, no, don't do that. Break a few 1-pointers out. You're going to find out that the 13 was really a 30, but start decomposing it, because really that big number means you don't understand it. So get down to the things that become something that you could see delivering in just a couple of days or demonstrate. So
makes a lot of sense. Okay, so I had a couple of questions prepared on the chapter you wrote in Beautiful Teams, but we want to make time for other questions. So I'll probably ask 1 or 2 questions regarding that chapter. So let's talk about the on-site customer. But first, let me tell our viewers that James wrote a chapter in Beautiful Teams where he described his experience introducing extreme programming to a company with the which was deeply process heavy. So let's talk about the on-site customer. So this is one of XP's core practices, but it's also one of the hardest to achieve, at least in my experience. You've written about how having the customer 5 yards away beats any amount of documentation. But what do you do when you can't have that? What's the next best thing?
So in the early 2000s, when we were first taking extreme programming to more than just, to teams with significant numbers of people, this became a big problem. And I think I'll attribute this to Lowell Lindstrom, who I mentioned before, suggested that you don't think of the customer as just a person now. We need this customer team idea, probably led by a product manager, and supported by, there were QA departments everywhere, right? So because software developers only did a little bit of testing, QA departments were doing a lot of it. So the idea we had was to, that Lowell had, was to form this customer team rather than the one person who's in charge. We were driving some product managers insane because their workload just became enormous with being the focal point of 10 developers, right? So we had to help them. We had to save them. And so because we were problem solvers, not dogma followers, extreme programming says on-site customer, you must have a customer. No, the problem is they can't do that job. How can we get that job done? And so Lowell's bright idea was, let's make a team out of the people that are working on the requirement side. And test really shouldn't be at the end. Test should be part of the beginning. And that was all part of Kent's thing too, right? There's test cases going in with the customer. Customer is going to produce test cases. So we're just expanding the people involved in that role. So I think in our training of people in extreme programming, I'm not sure if Kent Beck's second edition says on-site customer or says customer team. I'm not sure. But we, sanctioned by Kent at the time, was this idea of on-site customer team, where we try to get, somebody with authority, but that might not know all the details. But so that was one of the ideas there, would be to have that.
Okay, so the next question was actually about traditional QA versus test first development. So many organizations still have traditional QA departments and practice test loss development, often manual testing rather than automated. I'm speaking more of speaking more about mainstream development.
Mhm.
So in a recent talk, Kent Beck said he's 1,000,000% in favor of QA, but 1,000,000% opposed to a QA department, that it creates a misalignment of authority and responsibility and horrific incentives. He also observed that this model, common in the 80s and 90s, went away for a while, but is coming back along with waterfall. What's your experience when you walk into an organization with a separate QA team and test loss culture? What do you see, and what do you do to help them move towards developers owning quality through test-first practices?
Well, so in the context of that we just talked about with the customer team, the QA people would be part of the planning meetings, and they would be part of defining acceptance criteria, and might be part of the some of this stuff takes some time to bootstrap, of course. If we want to start using some automated test tool for requirements like Cucumber or Fitness or something like that, there is startup costs to that. Engineering has to build in the hooks to allow those things to be there, right? But so if we keep letting QA be at the end, we're never going to have a chance to do any of that work. So what I would suggest, and I think Kent has to speak for himself, but he's talking about making QA part of the team, not part of downstream of the team. We're moving them. You've heard of left shifting, right? Moving test to a proactive activity rather than a reactive activity. Okay, so instead of trying to find the bugs, we're trying to specify the behavior of the system. And so it is a shift. Now, should there be some people hanging out at the end to make sure? Maybe, because all these companies are in transition continually, right? to how to work and that sort of thing, and it's hard to get something out that works. I do believe, more careful work and reliance on automation for a lot of the tests and the discovery of, CI/CD is kind of a natural conclusion to extreme programming. If you were to do extreme programming and keep getting better, you'd end up with CI/CD. Now, what's interesting is that CI/CD is being pushed on the industry without the incoming quality checks that extreme programming would provide. So I'm thinking that this desire for instant deployment, right, continuous deployment, has a chance of bringing in the quality upstream practices that need to make that successful. That's my hope, right?
I gave a talk in last year's DevOps Days here in Cairo, and it was about TDD and DevOps. So I presented a use case, a real use case, where we were using the DORA metrics to measure how efficient was the DevOps transformation in a big organization. And we were surprised that there was very little DevOps did. Why? Because they were still doing test loss and doing manual tests. So there were absolutely no changes in the lead time for development, no changes in deployment frequency, because still testing would take a whole week. Okay, deployments take 1 minute or 5 minutes. That's great. But before the deployment, you have all this manual work being done. So really, CI/CD and DevOps is worthless without test first and automated tests.
Yeah, I guess, so if you think CD is just about the taking a known good binary and getting it into the right machine, that's like thinking that CI is using Jenkins or whatever, whatever the tool of the day is. No, it's the practices that allow you to deliver today, because, an important bug came in last night and we're fixing it and we want to deploy it today. The best the companies you're talking about could do is in a week. And then it would be bundled with a bunch of stuff that probably is broken because they don't have their processes in order, right?
There would be a fast lane, which is basically a shortcut. Like, let's not do testing and let's just ship it if we're confident that it's going to work.
And what developer's not confident? Come on.
Okay, so let's move to 2011 when you published Test-Driven Development for Embedded C. Now, what gap were you trying to fill in this book? Now, we know that embedded programming is the hardest environment for TDD. No hardware available, tight coupling to hardware, real-time constraints, resource limitations. So yeah, tell us about the book. What gaps was it filling? And what's different about practicing TDD in embedded from mainstream applications?
Yeah, okay. So I'll start with the last part of your question first, which is there's no difference. An embedded application and a mainstream application, they both have the same kind of problems. They depend on something. In a business application, you depend on a database or something. In an embedded application, you depend on the real world or some stimulus from the real world. And at some level, it's about managing dependencies. So I think us people that came from the solid world were able to adapt to extreme programming pretty quickly because we've already been thinking about breaking dependencies on problems. And in TDD, we got to break dependencies on our problems. Okay. And if I'm in embedded, maybe I never would have thought of doing that before. I would have thought of, oh, here in this line of code here, I need to blink an LED. So you might have a little call, blink LED. Now later, maybe blinking LED is not the right thing to do. It's, the event now requires a message to be sent on a network. So we got to separate the core application from the outside world. What else talks about it? Hexagonal architecture. So you'd end up with hexagonal architecture if you were practicing TDD and knew about solid. You might not draw a hexagon and name things ports and adapters, but you'd end up with pretty much the same architecture if you were thinking of those things. So I really like that there's a name for it now with Alistair's hexagonal architecture, and where you end up. So it's something that we can strive for. Let's see. So there's that part of it, and then also embedded programmers, at least around the year 2000, they didn't get out much. Okay, they're in their world. They know about the hardware, they know about the software. They're trying to get things working. And just like me, early in my career, I learned this hard thing. I must know everything by now. It takes a while before you actually realize there's other, and you may never realize that there's other things that could benefit you if you don't go looking. If I wasn't fortunate on that day in December 1999 to have gone to extreme programming immersion, I might not have bumped into TDD either, right? So right away, because of my realization of the problem that embedded systems developers face, historically, no hardware while you're developing the software, I thought I should go, as I gained some experience, a lot of it with that first client there, Motorola, I should start writing about this and try to get speaking spot at a conference. So there was always an annual embedded systems conference, not Microsoft, embedded systems. And there'd be two of them, one in the Boston and one in San Jose. And so I started submitting to those, and, the crowds were not that happy to hear me talk about extreme programming. Well, what does that have to do with us? That's something for Java programmers. No self-respecting embedded systems programmer would have gone and listened to anything Bob Martin had to say about how to program in Java, because that's not their world, right? So they wouldn't be thinking that there's anything to learn there. Now, the thing is, crossover ideas between those subfields, right? So I was lucky enough to have felt the pain of no hardware, so that when I saw a way out, it's like, hey, wait, here's a way out. And so I felt my mission was to start to bring that to people that weren't going to bump into it otherwise. And that's why I wrote the book. I first started talking at conferences and writing some papers. You can find them on my website. And then, the effort to write a book takes a long time. I started writing it in probably 2008. It took 3 years to get through it. It's hard. It's hard work to get it there. But that was the motivation. Was I wanted people to enjoy the thing that I could see as freeing them from this the target hardware bottleneck, as I call it in my presentations, and I think I called it that in the book. So that's the genesis there, the story there.
Yeah, and I liked how you started the answer to the question. So you've discussed the concepts you've talked about in clean code and clean architecture, with basically the boundaries and clean embedded architecture.
Yeah.
And I think what you're trying to say here is that this is basically the enabler for doing TDD in embedded software. Is that correct?
Yeah. Yeah. And you mentioned in your kind of things you might want to talk about this. What if there's an operating system or there's this IoT infrastructure that I need to use, right? So my code that I want to be able to test automatically can't really interact with the operating system and can't really interact with the IoT system because I need to control its world. And here's where hexagonal architecture, solid principles, clean code, this breaking of the dependencies on the real world. This is where the test-driven developer will have to design in those flexibility points, which are going to save you in the next release of your product when someone changes that hardware. It's going to save you because you had a flexibility point. You made it easy to change in the future, even though you didn't need it yet. But for test, you needed it for substituting in the fake representation of the operating system or the fake version of the IoT transmit function or whatever it might be, or the get message from the IoT network, right? Those calls had to be substituted during test so that we could drive our code through all the scenarios that may be nearly impossible to drive through in a predictable way in a real-time system, right? So if I need a certain sequence of messages to come in and then lose a certain message in the sequence and have it recover and not crash the airplane or whatever it might be, right? I don't want to have that first run when the airplane is having difficulty. I'd want to know that scenario is working before that, right? So it's the only sensible thing to do. Kent should have named it sensible programming, but then no one would have paid attention.
Yeah, exactly.
I think if you talk to him, I think he had floated some crazy names to us when he was telling us about the name of extreme programming. He goes, I thought I'd call it sensible, or but then nobody would have cared. Nobody would have looked.
Yeah. Okay, so let's move to zombies. So you created this approach to guide test design. But there's a story behind it, something about Kent Beck and Ward Cunningham and the concept of a test list.
Now you're going to talk about zombies, and I better put my zombie background on.
Yep.
Well, okay, so these are people that died, and they don't. No, I'm sorry, you don't mean that. Okay. So the let me just change what I'm looking at here.
Sure, take your time.
Oh yeah, surprising about the people stuff. We didn't talk about that. All right, this is a question I get all the time. I won't know what test to write. And actually, so in my training classes, what I used to do was have people experience TDD and then say, how'd that go? And, ask them, what did you think? And then the person that was probably responsible for me being there would say, oh, this is going to be great. It's going to help us so much. And everybody else is quiet. And then one day on my way to one of my training classes, a friend of mine said, you should read the book, Teaching from the Back of the Room. And I looked at it, and it basically had something I should have known long ago. It said, if you can ask somebody for a question,
have them write down the answer, because they're going to be intimidated to answer in front of their friends and colleagues, and you're not going to get honest answers or any answers at all. And so kind of the TQM stuff. So I started asking people, what concerns you about test-driven development? What did you like about it? Okay, I asked those two questions. Usually like first, and make them think of something that they like. They like the feedback loop. They like they like the confidence, but they think it's going to take too long and they won't know how to write the test. They won't know what test to write. So I had to talk about this a lot. And in the beginning, I remember, and I wrote about it in the book. I called it 01N. And in 01N, I wrote a little thing about it. Basically, do the simplest thing that could possibly work is what Warden Kent would say. Where is that? I don't have it written here. But in the book, I talked about 01N. And, start with something simple. Oftentimes the examples were a stack or a FIFO or a queue or something like that. And so the sequence kind of builds nicely with that problem. But start really simple and then do something, then do the next simple thing and the next simple thing, and eventually you're doing the hard stuff, okay? So I was talking to my friend Tim Ottinger, and I know he's been on your show, and so when I was talking to him, it's like, yeah, we're talking about this, is there another name for it? He goes, yeah, that's 𝗲𝗲𝗃. 𝗲𝗃, 01 many. I said, well, what's special about 𝗲𝗃? He says there's only 3 numbers that matter in computer software. It's 0, it's a special case. 1, it's a special case. And then the rest, they're not a special case. Well, what about 2? No, 2 is just the first of many. 2 is not a special case. It's like, oh, okay. Having that in my back pocket now and describing to people how I come up with test cases, I'm thinking of the 0 cases. That's, let me show this picture here now. So it's a different kind of acronym. It's 2-dimensional acronym. And over on the vertical axis, we've got 0, 1, many. Okay, so I got to start with 0. We've got this, and I'll use object-oriented technique here, or vocabulary. So I've got a brand new object. What could I ask it when it's brand new? What should be the post condition to create? Okay, so I've got a brand new object. I had to instantiate it. So this is a boundary from object exists to boundary object doesn't exist to object does exist. So there's an edge condition there. And then I need an interface for the thing that I want to ask it about. So if I was building, and I usually use circular buffer as my example here for this. So if I had a brand new circular buffer, I should be able to ask it a couple of questions. I could say, are you empty? And it would say yes. Are you full? And it would say no. And how much stuff could you hold? And it would tell me its capacity. I'm kind of done with the 0 tests now. Okay, so I've got some basic, and they're all hard-coded return results in those. But I've got the interface now, and I have some important boundaries, and I've got an idea of do I like the interface or not at this point. So in a way, this is a bit of high-level design. In my design UML, I might have the name of the function there, but I wouldn't have any of the details. I'd be working out the details in the code. When I get to 1, it's like, okay, what's something I can do to this object now that might change something about it? And so, of course, with the circular buffer, I would put something into the circular buffer. And then it would no longer be empty, and it wouldn't be full unless it was a size 1 circular buffer. That sounds kind of stupid to have one of those. And so when we're in the 1 case, we're usually defining new interfaces again of all the different things we'd like this object to be able to do. So now after just a few tests, what we have is the full interface defined of the object, and I've got the first user of that object, the test case, and I can look at it and say, I like this interface. Or maybe you can look at it and say, I don't like this interface, in which case it'll be cheap to fix right now. Okay, but maybe you won't know enough to fix it, but at any rate. And then you work your way into the many, which is about the generalized behavior. So you've worked out a bunch of specialized things, and then before you're done, you know how when you're in the details, you might forget something. And so you want to take a step back and think, did I forget anything? You mentioned test lists before. I would have done a test list beforehand.
before having done this, right? To have the idea of all the things I want to test. I want to test, tests around being empty, tests around being full, tests around wrapping around, tests around overflow, and tests around underflow. I would have probably made up that list. It wouldn't have directly mapped to zombies. But then I would, with that in mind, start down the zombie path.
Yeah.
Okay.
Makes a lot of sense. Actually, when I teach TDD and I talk about zombies, I talk about it as a way of coming up with a test list. Okay. But your idea also makes sense that you may want to first start with that and then, go towards the zombies approach.
Well, you'll never have a full test list in anticipation.
Yeah, exactly.
So in anticipation, you come up with what you could think of then, and you don't really care that you didn't think of all of them, because once you get into the details, you'll think of the rest.
Yeah, makes sense.
Yeah.
Okay, so thanks a lot for that, James. So we're almost done. So let's talk about the future. So we're seeing an explosive growth in IoT, autonomous vehicles, edge computing, and there's also artificial intelligence. What's your take on artificial intelligence role in software development and engineering?
Well, I've only done a little toying with it. And I wanted to use groq to help me with some programming in an area which I don't normally program in. And I felt like it helped me a lot. What I wanted to do is automate the production of PDF files for my training classes, because I have a lot of little modules and it's a manual process, and I hate manual processes, and I'd rather spend a day automating them than 2 minutes doing them. So I got some help from groq, and groq confidently would give me wrong answers time after time. And I would have given up if I didn't have this predisposition to let me go back to my other view. Predisposition to working in small steps. Okay, so groq, open up this Keynote file and produce a PDF formatted like this. It failed, but it managed to open up the Keynote file. So then, because of what I understood about, it got something right, and because I'm used to working in small steps, I kept prompting it to just go the next one step. If I gave it the whole job, it would give me a big elaborate thing that needs to be debugged. And if I gave it step by step what I wanted, I got little things that needed to be debugged, but I could get them working. And in a few hours, I had something that I would have given up on if I did it by myself. Because I wouldn't want to learn that much AppleScript. So it was very powerful for that. I'm also seeing guys I respect that are building it into their workflow. I haven't done that yet. I know Uncle Bob is, and I know Jason Gorman and some of the other people I hang out, follow on LinkedIn. Other ones I'm not mentioning now because I don't remember their names, but that are integrating. Paul Hammond, I think, is the other name I'm searching for. Integrating Claude Code and such into their workflows, and they're getting to train them to work in small steps. I think we're not at the point of any pedestrian walking up to a computer and asking for an app and getting something that's meaningful. I think you need skilled people to be able to walk through the details. And I watched Bob's episode, and I think he's right. We're just bringing the level of abstraction up. We still are going to need people that are detail-oriented enough to get these apps to work properly. And so AI is going to probably help that a lot. That's what I would expect.
Makes a lot of sense. Okay, so after decades of building software, coaching teams, and shaping how our industry practices TDD and Agile, what advice would you give to software engineers today, whether they're working on embedded systems or application development?
I'll suggest one thing for starters, and I wish they taught this in university. Work in small steps. Okay, so got a brief story about this. If I'm bringing up a new web page on my website, Ruby on Rails, first time I did it, I didn't know anything about it. So I read the manual, batch mode, wrote all the code, tried to run it. No, didn't work. Debug, read some more. Still didn't work. After a whole day, I managed to get it to work. And then the next day I got to spend chasing down all the things I shouldn't have changed on my way to making that one thing work. Now I can do that same activity in about a minute because of small steps and cause and effect. If I try to and so you can take the small steps and cause and effect to any problem. That I use it when I change the light switch in my house. What happens if I don't do anything? Well, the light switch doesn't work. Okay, the web page doesn't come up. I get a 404 error. Go to the right place to make the next thing that you'll be able to see a visible response to. That's add the route to my system. Now I get controllers missing. Then I add the controller. Controller method's missing. Then I add the controller method. View is missing. Then I add the view. Hello world. Now I've got the path through the thing, and small steps kept me from having to fix it later. I've got this saying I like to use. It's easier to keep the system working than to fix it after you break it. And so small steps embodied with that perspective, I would say that. Now that could lead you to TDD. I ended up there from learning TDD back to that to see that's the underpinning of TDD, cause and effect and small steps. So learn that, if anything. Then you can learn it through TDD too. Be happy to teach you.
Great piece of advice, James. Thanks a lot for that. So before we wrap up, what's next for you in terms of coaching and training? How are you continuing to teach TDD for embedded C, C++, and share these ideas with new generations of developers?
So I'm doing a little still live remote training. I'll go on site every now and then. I'm not that interested in traveling and as much for work. I do a little bit of it, but not too much. I built a system that I started before COVID that really helped me be able to deliver training remotely. So when other people were freaking out at the beginning of COVID and their training businesses now collapsed because they couldn't go anywhere, I'd already had about 5 years of experience doing the remote delivered training. And I've built up my system now so that for some uses, I don't even need to be there. I have a full self-paced TDD for embedded C and C++ training class. When I do live training, what I do is it's a mixture of attendees would do a couple hours on their own using my system. Then we would be together for the exercises and all the debriefs. And then they would work on their own again for another couple hours, and then we'd be together the next day. It allows me to span a lot of time zones and still have the important, immediate feedback time during the exercises. They can watch a presentation on a video, just as well as me doing it live. And so that has evolved into a completely automated system, which a couple of my clients have used, where they take on the facilitator role of the training class internal too. So individuals can take it by themselves, or somebody could facilitate it in their class. So that's how I'm hopefully going to be able to help more people with learn these modern practices. But I'm one guy, so I can't do it because there's 5 million embedded systems developers, and I'm not going to be able to get to all of them unless they come to me. So
yeah, that's great, and I highly recommend your trainings. It's they're really great. I mean, I attended a very short class, and it made a big difference. So I can imagine how your other trainings and services will make a difference. So
well,
yeah,
appreciate that.
Thanks a lot for that, James. Okay, so James, this has been an extraordinary journey throughout the history and the future of our craft. Thank you for your time, your wisdom, and for the countless ways you've shaped how we build software, from inventing planning poker to championing TDD and embedded systems to helping write the Agile Manifesto that changed our industry forever. Your work reminds us that great software isn't about following trends. It's about discipline, craft, and caring deeply about what we build, whether it's writing tests first, designing with boundaries, or bringing rigor and quality to the most resource-constrained environment. So
Thanks on that. I really appreciate it. And you're an amazing interviewer, if I should call you that. You're so well prepared. I really appreciate it. And I just would encourage people to be problem solvers and not dogma followers. All right, and get those small steps. Thank you on that. Thank you very much.
Fully agree. So to everyone who has enjoyed this episode, be sure to check out our previous conversations with other pioneers of software engineering. And don't forget to follow Tek Caffe for more episodes that celebrate the art and science of building great software. So until next time, stay curious, keep learning, and keep your tests green. And so that Ahmed Misbah, and this has been exactly. Red, green, refactor. So I'm Ahmed Misbah, and this has been the Tek Caffe Podcast.
Thank you very much.
Thank you.